Hi, this is Mr. Manley. In this video, I'm going to talk about the graphs of sine and cosine. We're going to start off with what the parent function looks like. What does your basic sine graph look like? What does your basic cosine graph look like? And we'll take a look at both of them. Sine. Now, remember, if we were graphing anything in the past, typically we go like this. We go x, y, and we go 0, 1, 2, and we find some points. We're essentially doing that here, but we're not going to use 0, 1, and 2 because those are not convenient values to use for sine. If you think about sine and what values you can evaluate, we're going to use values like pi over 2. We will use 0 as well. We're going to use values like pi, okay? And then it goes the same thing for the scale. So instead of going 1, 2, 3, which I could do, I am going to instead do the more convenient values of pi over 2 and then pi, 3 pi over 2, and 2 pi. So this is just breaking up the number line at more convenient places because we're working with trigonometry. The 1, 2, 3, 4, -1, -2 are still on the number line. We're just ignoring those because they're not convenient to us. We're going to focus in on the pi and the factors of pi because those are convenient values. So sine x is going to graph by finding 5 key points. Just like if I were graphing a parabola, I would find the key point of the vertex. And if I were going to graph a line, I would find the key piece of information of the slope, and then maybe the key point of the y-intercept. For sine x, I am going to have these 5 key points. And the key points are 0, 0, pi over 2, 1. So I'm going to do my y scale of 1 here. And then pi 0, and 3 pi over 2, -1, and 2 pi 0. So these are the 5 points in the base sine function, your parent function for sine, or your most simple version of the sine function. And that's one cycle, also known as one period of the sine function. And then it continues infinitely. I would continue with this in both directions, like that. Okay? So the important thing here is that you understand that when you're doing a sine graph, everything is going to be varied based upon these 1, 2, 3, 4, 5 points. So you need to know those 5 points: 0, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Same thing for cosine, except my 5 points are shifted. And my 5 points are, and we'll do the same scale here, pi over 2, pi, 3 pi over 2, 2 pi. And my 5 points are going to be 1, 2, 3, 4, 5. And that's my base, or my parent function for cosine. That, and it continues infinitely in both directions. Now, from here, what we would be interested in are transformations of this function. Like a very simple transformation would be, so I'm going to focus on the sine function for a minute here. So a very simple transformation would be, we'll call this y1, and then say I had y2 equals sine x minus 1. So do you know what that does as far as the transformation goes? Hopefully you narrow it down to two choices. You're either moving up and down or you're moving left and right. And if you remember your earlier work from Precalcus, you would know that it moves down 1. And then all I would have to do is take every point here and move it down 1 unit. 1 unit down, and I would get this. All right, I don't know if you can see that well. Maybe I should do it in a different color. You would get a graph that looks like this. So it's just the sine function. It was all moved down 1 unit. That's where my focus will be here. I just want to look at a couple of different transformations that we can do with these sine and cosine functions if you can operate off of that base knowledge. So here we have a sine function, and what's the difference? You can see the difference here. It's this minus 2, the factor of minus 2 that is in front of the sine function. And maybe you have an idea about what that does. Hopefully you do. The negative is going to give us a reflection, and the 2 is going to give us a stretch. So let's go down to our graph here, and we'll get our values on the x-axis here. And now let's remember what the basic function looks like. The basic function looks like this: 1, 2, 3, 4, 5. So what is the function? What's going to happen to the function? It is going to be, the negative is going to reflect it. So can I do the reflection here? Of course, these points here, there's nowhere to reflect them if they're on the x-axis. And of course, this is a reflection through the x-axis. That's this negative here is a reflection through the x-axis. That's something else we need to remember. Okay, so now this point though, right there, that point, I can reflect that down through the x-axis. So let's go ahead and do that. I'm going to go down instead of up, and then this point over here, I'm going to put it up instead of down. So right there I've got negative sine x, and then I need to take into account this 2, that everything is going to be stretched. So this point here, this point right there, I'm going to move it down 2, and I'm going to move the other one up 2, or stretch it up to the 2. So let's see what that looks like. I'm going to take this down to 1, 2. Of course, again, I'm using the scale of 1 like that. And then this point over here, I'm going to move up 1, 2, so it's going to go to 2. So it doubles, okay? It doesn't shift, it doubles. So I'm going from a 1 to a 2, and then it's just connect the dots, right? Now, if you were graphing this on ALEKS, you would just hit the graph icon and it would graph it for you. And again, of course, this continues infinitely in both directions, kind of like so. Okay? So that's one transformation. And then another type of transformation is going to be, I'll use the cosine function to demonstrate this transformation. Okay, so what is happening here? I've got this this 3/4 x, right? What is that doing? Well, let's see if this makes sense to you. If we said this is giving us a vertical stretch, see that 2 there? That is giving us a vertical stretch. Right? The 3/4 likewise is giving us a horizontal stretch. All right, so it's shifting it horizontally. We don't have to worry about whether we're thinking about it as a stretch or a shrink or whatever, because here's what we're going to do with this. We are going to say that, remember back here, back at the beginning, we talked about, or I talked about the period, right? That the period of the function, like from here to here, so the period for one cycle, I use this word period here. Do you remember what that was? The period for one cycle is 2 pi. Can you see that? That as I go from the first point to the last point in one cycle, that is happening over 2 pi units. Okay, so this is what the period of the function is. When we get this change here, when we get this 3/4, that changes the period. And here's how it changes it. First of all, let me say something that I could have said earlier, but that I could say that the general form of these functions is y equals a cosine b times x. So we are only going to be looking at functions where a changes or b changes. And we could also like do a plus c out here as well, but we're not going to look at that. So a changes or b could change. And this b is telling me the period. The period of, I'm going to put this down here, I think, down right. The period of these cosine and sine graphs, the periods are 2 pi over b. Okay? So if I had, like, I'm going to take this 3/4 out for a moment. So if that 3/4 wasn't there and I just had cosine x, what would the period be? It would be 2 pi over 1, which is 2 pi. And that's what we saw. We saw that it goes through a cycle in 2 pi units along the x-axis. But in this case, I want to go 3/4. So my period for this one is 2 pi over 3/4. A lot of students have problems with these fractions. You got to figure this out. This is going back to elementary school, and you're not remembering your fractions, and maybe depending upon a calculator too much over the years. But this 2 pi over 3/4, it's equivalent to 8 pi over 3. And then the really important conversion now is to convert this to a mixed number, from an improper fraction to a mixed number. So that would be 2 2/3 pi. So what that means is, now if you remember the cosine graph went like this, right? Just really quickly, just saying what that, and it went through that cycle like that in 2 pi units. So what this period does is we're going to go through that cycle, but it's going to be in 2 2/3 pi units. So how are we going to do that? I'm going to have my scale laid out here with my pi and my 2 pi. I'm going to have the y scale of 1. Just like I did on the base function, I'm going to start at y equals 1. Now, I need to draw this so that it goes through this cycle like this, goes through that cycle in 2 2/3 pi. So I'm going to have to do some counting here. 1 pi, right there, there's 1 pi. And how many squares are there? 1, 2, 3, 4, 5, 6. All right, so how many squares would be 2/3 of that? What's 2/3 of 6? Of course, I hope you can get that it is 4. So that's where I'm going to go over here. I'm going to go 1, 2, 3, 4. There's 2 2/3, and that's where I want to end up. So I want to end up there, all right, and then I'm going to go through the cycle and end up there. Got to get a little bit more specific than that. Now, do we understand that, like in this cycle here, that the bottom of this happens at the halfway point? So I just got to figure out where's the halfway point between here and here. Well, what is it? It's each that's 6 squares. That's 12, 13, 14, 15, 16. So there's 16 squares. So I'm going to count off 8 squares, and that'll be my middle point. So there's 6, 7, 8, and then that's my middle point, so that's my bottom. That's the bottom of the cosine graph. All right, now I need to get the curve to go down there and up there, like that. Again, I need to be a little bit more specific. So I need to go halfway. I need to go halfway between these 2 points, and that's where I'm going to cross the x-axis. So that's going to be 1, 2, 3, 4 of these. And then halfway between these two is where it will cross the x-axis again. That's 1, 2, 3, 4 there. And then I just connect my dots with a curve, right? So I'm going to curve through there, and that's what the cosine curve looks like. And of course, it continues infinitely in both directions. And you don't have to worry about that if you're doing it by hand. If you're doing it on an ALEKS online program, you can hit the graph icon and it'll graph it. So there you go. We've got the basic sine and cosine functions, and then we're looking at a transformation, possibly a reflection. Certainly could be looking at a stretch, a vertical stretch, or shrink. I could shrink it vertically, and then we're looking at a horizontal stretch or shrink. And you've got to understand this. In order to do that correctly, you've got to understand this concept of period. And you're going to have to be working with some fractions there probably as well.